Here are our notes for Unit 2.2, Properties of Parallelograms. Our objectives today are first to learn the definition of a parallelogram. A parallelogram is a quadrilateral with two sets of parallel sides. Notice the word quad means four, lateral means sided. So a quadrilateral is a four-sided figure. A parallelogram is a quadrilateral with two pairs of parallel sides. We mark that here with little arrows. So we would say that segment AB is parallel to segment DC. AB is parallel to DC. The second set of parallel sides is AD and BC. Segment AD is parallel to segment BC. Next, we're going to look at some properties of a parallelogram, but before we do that, let's look at this program called Geogebra, which shows us a parallelogram that I can move. This maintains the property of a parallelogram in that the opposite sides are always parallel no matter what I do. And let's notice a few things. First, opposite sides are the same. We see 12.1 and 12.1. Also, we've got 8.7 and 8.7. Next, we notice that the diagonals go across from A to D. The diagonals, here I'll make that line a bit thicker. The diagonals bisect each other. There's my diagonal. And so we can see that EA is 8.5 and ED is 8.5. It's cut in half by point E. Likewise, the diagonal going the other way, BC, is cut in half. I have another sketch that we can take a look at. And we can look at the angles of a parallelogram. We'll just open this up in Geogebra. These are available for you, by the way, in our Canvas course. What I want you to notice here is that this maintains its properties of a parallelogram. And look at the opposite angle. So here I've got angle C at 82.7. And across from it is another angle that's the same, 81.8, 81.8. And then in the other corner, we've got 98.2 and 98.2. And those angles are, the consecutive angles are also supplementary. In other words, they add up to 180. So let's record all of this information on our note sheet. So first, if a quadrilateral is a parallelogram, then opposite sides are congruent, meaning that AB and DC would be the same, and AD and BC are the same. They're congruent, and I can write in an example. AB is congruent to DC. Again, that'd be AB and DC. Those are congruent and parallel. And then I can say that AD is congruent to BC. So AD and BC are congruent and parallel. Okay, next. If a quadrilateral is a parallelogram, then opposite angles are equal. Well, you actually can say two different things, but that mean basically the same thing. You can say they're congruent, meaning they have the same shape. Or you can say their measures are equal. The measurement is the number that you get when you actually measure it with a protractor. Here we can say that this angle, DAB, the measure of angle DAB, we could say, is equal to the measure of angle BCD. there's another set. We could say that ADC is equal to the measure of angle CBA. Next, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. This means they sum to 180 degrees. So an example of consecutive angles would be angle D and angle C. So I could say the measure of angle ADC plus the measure of angle C would be DCB. When I add those together, I should get 180 degrees. Finally, we can say that if a quadrilateral is a parallelogram, then its diagonals bisect each other. To bisect means to cut in half. So here we can say that, let me get a different color here, DE is the same as BE. And we can say that AE is the same as EC. AE is congruent to EC. So let's think about why these properties are true, and let's start with a figure that we know is a parallelogram. So let's start with parallelogram ABCD. We're going to say that that's our given piece of information. And if it's a parallelogram, then we know that AB is parallel to DC. And we know that AD is parallel to BC. And we know that because of the definition of a parallelogram. Now what I have is I have parallel lines cut by a transversal, and in the previous sections we learned that alternate interior angles are congruent. So angle DCA is going to be congruent to angle BAC. And I also know that this angle, angle BCA, is congruent to angle DAC. And the reason for both of those are that alternate interior angles are congruent when the lines are parallel. Okay, next, I'm going to say something that may seem obvious. I'm going to say that this diagonal, AC, is congruent to itself. That's called the reflexive property. It's helpful to actually state that it's true because it allows us to see more easily that we have two congruent triangles, and they're congruent because of angle, side, angle. So now I can say that triangle ADC is congruent to triangle CBA. And the reason I know this is because of angle, side, angle, triangle congruence. And once I've proven that the triangles are congruent, now I know that corresponding parts of the triangles are congruent. So I could say that AD is congruent to BC because they are corresponding parts of congruent triangles. I can also say that DC is congruent to AB corresponding parts of congruent triangles are congruent. So what I've done here is I've proven our first example. If a quadrilateral is a parallelogram, then opposite sides are congruent. So I've tried to give evidence for that, and my evidence is based on similar triangles. Let's do some more examples that have to do with calculation. So I'm going to start with example 1. It says find the missing variables. And what I'm going to notice right off the bat that is indeed this is a parallelogram. You can see the marks for parallel. And we know in a parallelogram that opposite sides are the same length, which means that x and 10 are the same length. So I can say that x equals 10. That's my first variable that I figured out. Done. Okay. Next, I can look at another pair of opposite sides. I can see that y and 8 are on opposite sides, and they must also be the same. So y equals 8. Finally, I know that opposite angles are the same. So this angle A is the same as angle C. So I know that 2z equals 50, which means that z equals 25. And that's my third variable, and now I've done it. I've solved and found the missing variables. In our next example, we have consecutive angles. Again, consecutive angles means that they are next to each other. So B and C are consecutive. And we know that consecutive angles sum to 180 degrees. Which means that when I add these together, when I add 2x plus 15 plus x, that's going to make 180. And now I can solve this using algebra. I'm going to combine my like terms. So 2x and x is 3x plus 15 equals 180. I'm going to subtract 15 from both sides. I'll continue my work up here. I end up with 3x equals 165. And I'm going to divide both sides by 3, and I end up that x equals 55 degrees. And that's this angle here. 2x plus 15 equals 125 degrees. And now I know that I did my work right because 125 and 55 does indeed make 180. And I can find the other angles, although it doesn't ask me to. I'm going to go above and beyond. I can find those other angles because I know that opposite angles are the same. Let's move on to question 3. Question 3 says, if the measure of angle 1, that's right here, is 20 degrees, and the measure of angle 4 is 120 degrees, find all other angles. Well, first and foremost, I can tell that 3 and 4 are vertical angles, so 3 is also 120 degrees. So just a reminder that vertical angles are what you get when you take two straight lines and cross them And the angles that are across from each other are called vertical, and they're always the same. Next, we've got angle 1 and angle 2. Angle 1 and angle 2 are alternate interior angles, so angle 2 is 20 degrees. And just a reminder, with alternate interior angles, if you have two parallel lines cut by a transversal, then your alternate interior angles are the same. Okay, question 4. Find the value of y. Well, here we're going to use a property of diagonal. So I'm drawing in the diagonals. The diagonals bisect each other, which means that t is right in the middle, which means that 8y plus 18, this segment, must equal tk, which is 12y minus 10. And now it's just a matter of algebra to solve it. I'll subtract 8y from both sides. And I'll add 10 to both sides. And I'll divide by 4. And I get that y equals 7. So there is the value of y. Y is 7. Okay, for my last example, I've got an example of what's called coordinate geometry. It says 3 vertices. Oh, this is spelled wrong, but I can fix it. There's no I there. 3 vertices of parallelogram WXYZ are W is -1, -3. I'm going to put in my numbers here just so I can make it a little easier for myself. So -1, -3 was over -1 down 3. X is -3, 2. Y is not given, and Z is 4, -4. Over 4, down 4. It says find the coordinates of vertex Y. Okay, so when I draw in my sides here, I notice that vertex Y is missing, and I feel like vertex Y should be somewhere around there, because then I'd have a parallelogram. But I need to know exactly where it is. I'm not just going to kind of make it up. I'm going to use a little bit of science here. So what I'm going to do is I'm going to count how far over. I want a better color. There we go. How far over, or how far down rather, and how far over do I have to go to get from W to Z? And what I notice is I go down 1, my rise is -1, and my run is 1, 2, 3, 4, 5. And what I'm going to do is do the same thing, starting at point X. I'm going to do the same thing. I'm going to go down 1, and I'm going to go over 5. And when I do that, I can see exactly where point Y should be. Y should be at 2, 1. And now I can fill in my last side. And I've got a parallelogram. And I would encourage you to look at these triangles and notice they are the same. That's how I figured it out. The nice thing about doing it that way is it also helps me figure out the next question. The next question is asking me about slopes. So the slope of XY is the rise over the run, but the rise was -1, and the run was 1, 2, 3, 4, 5. So there's my slope of xy. And the slope of wz was the same. Now I just need to do my other pair of sides. So now I'm looking at xw. And for that one, I go down 1, 2, 3, 4, 5. So the rise is -5 and the run is 2. So the slope is -5 over 2. And I get the same thing for yz. All right, we did it. We've proven it's a parallelogram because we have two pairs that are the same. One pair is -1/5, one pair is -5 over 2. My last question is to find the point where the diagonals intersect. The diagonals intersect at a midpoint. So let me draw in the diagonals. It would be good to do this with a ruler. And the point where they intersect is right there. It's over a half. And it's down 1. So this point right here is 1/2 -1. I'd also like to point out that it is a midpoint of a diagonal. So you also could figure it out by taking the x coordinates, that's -1 and 2, and taking the average, and taking the y coordinates, that's 3 and 1, and taking the average. If you do that, you get you get positive 1/2 and, oh, this is -3, and -1. You get the same answer as if you just look on the graph. So the point where the diagonals intersect is 1/2, -1. All right, you are ready to move on to the homework on page 372, 1 through 20, and number 27.